Hey class, today we're going to talk about graphing polynomial functions and mostly focus on end behavior. So when I talk about end behavior, I'm talking about what happens to the function as it goes towards infinity, essentially. Like if you think about a general parabola, we always draw these ends, we draw these arrows. And so I'm going to be talking about end behavior. I'm going to say, well, as I go on the x-axis and I'm increasing, so as I go to the right, my parabola that I've drawn here is going to continue to increase. As I go to the left, my parabola is going to continue to increase. And so both sides are going to be increasing. So that's the end behavior. And so that's what we're going to kind of talk about, because even and odd functions have very particular end behavior, and that'll help us make predictions about different things and help us model relationships with graphs later on. So first we'll start with just the basic linear functions. And so we're going to look at a bunch of parent functions. And so these are the end behavior for y equals x and y equals negative x. So this is just linear. So if you plug in 0, you get out 0. 1, 1, 2, 2, 3, 3, negative 1, negative 1. This is just your straight line. And so for a linear equation with the positive slope, as x increases, so as you go to the right on the x-axis, the y is also increasing. So as x increases, y also increases. And then as x decreases, you'll see on the left side here, the x-axis, as x decreases in value, so as you go more towards the negative, the y value also decreases. And then y equals negative x is just the negative slope of the line, so it goes down through the origin like that. This one's the opposite. So as x increases, as you go to the right, y decreases. Decreases. Oh, I knew I did something wrong in that spelling. Sorry. There we go. And then as x decreases, so as you go to the left on the x, the function increases. And it's worth noting that this is a x to the first power and x to the first power. So this these are considered odd functions because they have an exponent of 1, which is an odd number. And odd functions follow the same pattern, as you will see. So when it's positive, x increases, y increases, or x decreases and y decreases. And then when it's a negative odd, it'll increase as y decreases, x will decrease as y increases. So let's look at these ones. These are y equals x squared and y equals negative x squared. These are both even functions because the exponent degree of 2. Y equals x squared. If you think about, just a standard table, remember the parent function 0, 1, 2, 3 is 0, 1, 4, 9. So this has a vertex at 0, 0, 1, 1, 2, 4, 3, 9, and then you can easily get the other side if you just reflect that over the axis of symmetry, which in this case is the y-axis. This is the parent function. Now, in this case, as you go to the right or to the left, since it is opening up, the function itself is increasing in both. So increasing and increasing on both sides, going up. The only difference here for the negative one would be that instead of going up, 4, 9, it's going to go down. So over 1, down 1, so start 0, 0, over 2, down 4, and over 3, down 9. And then, of course, the same on the other side because it's even, that's a reflection. So negative 3 squared is still 9 times negative 1. And so if it's an even and it's negative, then it's both decreasing from the right and from the left. So as x is getting bigger or smaller, if x is increasing or decreasing, the function's going down either way. So for even functions, it's both either going to be increasing or both going to be decreasing. So let's look at this one. This one has x cubed and negative x cubed are a degree of 3, which is an odd number. So it is an odd function, an odd degree. So x cubed, let's just think about what it might look like to graph this. If you plug in negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 cubed is 0. 1 cubed is 1, 2 cubed is 8. And so if you were to graph those points, negative 2, negative 8, negative 1, 0, 1, 2, 8. You will see that the cube kind of makes this S shape, but it has the same end behavior as the linear one did. Remember, the line was the positive line. As you go to the right, as x is increasing, the function is also increasing, which is the same thing the positive line did. And then as x is decreasing, so as you're going to the left on the x-axis, the function is going down, the function is decreasing as well. The negative version of this is going to be the same thing except for that it'll be all negative. So negative 2 cubed is negative 2, and the opposite of that would be negative 2 cubed is negative 8, and then the negative out front would make it positive 8. So negative 1 cubed would be negative 1 times negative 1 would be 1. Okay, sorry, it's going to be this table if you plug them in. It's going to be the opposites because you have the negative out front this time. So that's going to reverse the direction. Negative 2, positive 8. Negative 1, 1, 0, 0, 1, negative 1, 2, negative 8. So this time it looks like this, which is going to be very similar to the end behavior of just y equals negative x, which is the last odd function that we did. So you're going to have this same end behavior. As you go to the right, as x is increasing to the right, the y value is decreasing in value. As you go to the left, as the x value decreases, the smaller x value that you pick, the larger y value that you're going to get. So the y value is increasing. And so that is an odd function. It's going to have the same end behavior again. And the last one we'll look at is another degree of 4. So it is an even function, so I would expect it to have similar end behavior to our other even function, which was x squared. So we're just going to do a standard like negative 2, negative 1, 0, 1, 2, so we can get an idea of what this would look like. Negative 2 to the 4th would be 2 times 2 is 4, times 2 is 8, times 2 is 16. And negative 2 to the fourth would still be positive 16. Negative 1 to the fourth would be 1, 0 to the fourth is 0, 1 to the fourth is 1, 2 to the fourth is 16. So you're going to have 2 to the 16th is going to be, or negative 2 16s way up here, negative 1, 1, 0, 0, and then 2, 16. So it kind of ends up looking kind of similar to a parabola, very narrow in this case, but it has the same end behavior. As you go to the right or the left, the bigger the x that you pick, the bigger the y value that will come out. If you were to do 10 for x, 10 to the fourth would be way up here. So as x is increasing, y is also increasing. And as x is decreasing, so the smaller value you pick at like negative 10, you would still get a y value that is increasing. So the positive goes up. The negative would be the same except for going down. So instead of positive 16, be at negative 16 and then negative 1. So it's going to look similar but facing down this time, which means as x increases, y decreases. As x decreases, y also decreases. So even goes the same way, either both up or both down, and odd has 1 increases as 1 decreases. So even, if the leading coefficient is positive out front, then as x increases or decreases, y just increases, up and up. If a is negative out front, as x increases or y decreases, or as x increases or decreases, y decreases. It's kind of a tongue tie here. Sorry. So both down. For odd degrees, I always remember it as like y equals x. If a is positive, so like positive x, it has a positive slope. So as x increases, y also increases. Versus as x decreases, y decreases. Then if a is less than 0, so like a negative coefficient, then it's like the negative sloping line. So as x increases, the function's going down. The y is decreasing in value. And as x decreases, the y is increasing. So these rules will help you with end behavior. I do expect you to know these. It does take a little bit of practice before you fully understand this concept. So do your best. Let's try a couple. So just looking at the function, if I was to identify the highest exponent, that means that this defines what type of function I have. So it is a odd function because it's cubic and a leading coefficient is negative. So I have an odd function with a negative coefficient. And so the cubic kind of looks like this and the odd goes like this because it has like a negative slope. So as x increases, as you go to the right, the y decreases. And then as x decreases, so go to the left, basically, the y is increasing. Okay, b, the highest exponent is 5. So this is a 5th degree polynomial with a leading coefficient of 2. So it is odd. It has a positive coefficient. This one was odd but had a negative coefficient. So essentially this is going to have a positive slope. So as x increases, y is also going to increase. Basically, as you go to the right, you're going up. As x decreases, the y is going to also decrease in value. As you go to the left, it goes down. In C, I have a exponent of 4 and a negative coefficient. So this is an even function with a negative value. This is like the parabola that's even, but it opens down because it's negative. So it's going to decrease and decrease on both, either from right or left. And then the last one has an even power again with a positive coefficient, which means it's going to open up. So either direction, it is going to increase in both or go up. Okay, so I can use this idea to help me graph. I know that this is an even. It's actually written in standard form. It's an even function. It has a leading coefficient of 4. My graph should end up looking like this eventually. So I'm going to just plug in like -2, -1, 0, 1, 2 into the function and get out the values. So I have -2 to the 4th power, so I'm going to have to use this little caret to the 4th power, and then +2, and then -2 to the 3rd power, minus 5 times -2 plus 1. Oops, that's not right. Here I have to go out of the exponent. Minus 5 times -2 plus 1. 11. That sounds better. Okay, then I want to copy that, except for changing all of the -2's to -1's. 5. Plugging in 0 is easy because 0 plus 0 minus 0 plus 1 is 1. Then I'm going to copy this again, except for I'm going to change them all to positive ones now. Get -1, and then one more time, except for that plugging in 2 instead. 12, 2. You get 23. Then I'll graph this. So -2, 11 is up here, -1, 5, 0, 1, 1, -1, and 2, 23 is up here. So I can draw this as it is, connecting the dots from right or from left to right. So connect from left to right. Now I feel pretty confident drawing my arrows and being done with this graph because I know that since it's an even function and it's positive, that it will increase on both sides of the graph, the left and the right. And so I know without a doubt that it's not going to turn back around and come down here. And so I will draw the arrows there. I don't need to go any further. That's a good sketch of that graph. And that's kind of what end behavior is used for. Do one more. This one's a cubic function. It's positive. So it's odd and it's positive. So the end behavior will kind of be like that. Y equals positive. Y equals x. So positive slope. So if we plug in the same values, -2, -1, 0, 1, 2, see what happens when we plug those values in. So this time it is -2 to the 3rd power plus 2 times -2 to the 2nd power. I have to use the right arrow to get back out of the exponent. Minus, and then -2, and then plus 3. So I get 5. If I copy it, copy that and change these into negative ones. I get 5 again. 0 would be 3. Copy that one more time and plugging in a positive 1 this time. 5. And plugging in a 2. And I get 17. So graphing that, I got negative 2, 5, negative 1, 5, 0, 3, 1, 5, and 2, 17. So that's going to be up here. So if I was to connect this as I have it, from left to right, it's going to look like this. Now, I know that this function doesn't just end like that. So I'm going to predict that, since I know that the end behavior is like this, so as the x increases, the y increases, and as x decreases, the y should also decrease because it is a odd function. So the end of the function should look like this. So I should be able to draw the rest of the function like that based off the end behavior, what I know about it. I could plug in one more term like negative 3 just to be sure, and one more to the left, and see if in fact that does work. Whoops. I deleted one too many, but there we go. And see what I get here. And I get negative 3. And so, in fact, negative 3 is just about exactly where I predicted it would go. So straight down there. And I knew that because of the end behavior, because it was odd.